Sober as a judge, there you go.
Speaking of judges, we are in residential real estate. 95% of the lawsuits, unhappy buyer going after the seller. And this is part of the problem as a realtor when I'm helping buyers and sellers out there in the field. Let's just, for the audience members, Tim, can you give a brief background on what your duties are?
What I do is structural engineering. So if it's a new house, an architect or a designer typically draws up the plans, then they come to me and I make sure that it's good for earthquake and wind load and the footings are good enough and the beams are sized correctly and all of that. So, and then when we do structural repair, which is what Mark builds, sometimes I'll create the plans, sometimes a draftsman will draw those plans up and then they come to me and I make sure that the underpinning footings or pilings are done correctly and spaced right and sized right and the connections to the footings are all good and all that kind of stuff.
Wow. Okay, Mark.
So I own MG Constructors and Engineers. We're a local Bay Area firm that specializes in usually structural related projects, but it can be decks off the back of a house or a building, or usually a lot of distress issues. So sometimes settlement foundations, sometimes roofs that'll fail. Sometimes Tim and I did a big project in Tracy where a big commercial building caved in the middle of a windstorm, that kind of stuff. But we do all kind of stuff, but a lot of residential and commercial.
Okay. Let's get right into the part in terms of I'm showing property as a realtor, and oftentimes there's a big yard, and sometimes a listing agent, the seller's realtor, is known as the listing agent, will say there's room to expand in the backyard. It's just almost a flip comment. They didn't check with the city or the county. They don't know what type of expanding type of measurements they can do in the backyard. Can you speak to how one would enlarge the footprint of the house on a lot? Can you give a...
I'll take that and then I'll hand it over to Tim when we get into the nuts and bolts. Well, there's a lot to that. So when a client's looking at a home or trying to expand or build, there are a myriad of laws that are there to basically tell what can and cannot be done. So first off, is the lot big enough and zoned correctly so you can push out? Then once you determine that by doing a submittal to the planning department, they typically will review what your proposal is, and if they accept it, then it's going to go into construction. That's when Tim's going to take that set of drawings and put the nuts and bolts to it so it can be built. He can elaborate on that.
Okay.
Okay, so let's say we've got a house and here's the house and the street is out here, and somebody wants to add on out here.
Right.
Okay, pardon my non-90 degrees.
Okay.
This is freehand.
By the way, let's do the lot size on this. Can you use the red for the lot?
Okay, so
let's do that. Here's
yeah,
the
maybe this is a narrow lot like this. So the only place they can go really is that direction.
Exactly.
And so we would see this all the time. Here's the thing, is that when you go and do this piece here is connected to the house here. In the world of structural engineering, what you have to keep in mind is when the earth shakes or the wind blows, this piece here wants to move. And it's going to impart load on this old piece here. What if this old piece was built in 1910 or something like that and is nowhere close to meeting any kind of earthquake codes?
I see.
Well, now you've just added to the problem of this thing was weak to begin with. And so codes have rules that dictate how much load we can add from here to here before we have to bring this house up to current code.
I see.
So let's say this house was built in 1910. How many pieces of that house meet current code, Mark?
Zero.
I mean, maybe one bolt or one nail or one stick.
Okay.
And so you're adding all of this new load to this. If this triggers an upgrade of this, suddenly this person who's only thinking of the dollars here now has to address dollars here.
Okay, but that typically happens in the field. People talk about how much does it cost per square footage to add this master suite.
Right.
And they don't think about the rest of the house.
Right, and this is a one-story addition, what I'm thinking of here. When if you want to keep going on this, I can show you what happens with two-story, because sometimes if the lot line is here, the only place to go is up. It's the same thing. All of this new load up above the house has to be supported on what's below it. It's going to change the loads on this. Now you've got upgrades down here way beyond the costs of just what's new.
Now the upgrades on this, so the existing house here is the towards the sidewalk there. Are we talking about in the crawl space with the post and pier and the foundation and all that? Is that what you would have to retrofit?
Okay, well, if let's go back to this example here. So we're adding on this piece here. Typically, this piece is going to have its own footing all the way around, except where it matches right here. If the floor joists or the roof span this direction, all of that load is going to wind up on that footing. The question then is that footing big enough? Also, if the roof is, and I'm going to do something funny like this, let's say the roof trusses go this direction and they bear on this wall. Now, if there's windows in this wall, you have to look at the headers in those windows. Are they big enough to support the weight of this additional roof on there? So all the action structurally happens right here at the mating line.
I see. Okay. Now, in terms of when you're designing something like this, what is the mechanism for the home buyer? Let's say the home buyer wants to add to this, and they really don't have time in a home sale. They say, let's say the back of the lot continues to go forever.
Yeah.
And they see neighbors next door that have gone out an extra 20 feet. So the real estate agents and the buyers assume they can go back 20 feet.
Yeah.
What is the first thing they do? Do they hire an engineer or a draftsman or a contractor?
Well, let me seize on something, because there's an opportunity here to be efficient and save a little bit of money. If this lot goes back, a smart way to go about this would be to build the structure not attached. So build it back here someplace, if you can do it, okay? And maybe you have a breezeway or something that connects it or something like that.
Okay.
But now you're not affecting this structure at all. So suddenly all of the cost implications and upgrades to this old existing building go away. This is structurally independent. Now all we have to do is deal with this per the current code. That's pretty straightforward.
Okay.
If you go up, that option is obviously doesn't apply. So a lot of times when you were talking earlier about the size of the lot restricting construction to just going up, that's not an option, right? Because you're going to build above the old one, and the old one's going to require the upgrade all the way from the bottom of the footing all the way to the top of the existing roof.
Yeah, and in that case there, to answer your question about crawl space and all of that, if loads come down through that house, you have to look at every affected piece. So you're looking in the crawl space at the footings in the crawl space, you're looking at the floor beams in the crawl space or up in the ceiling. You have to look at the whole thing, and it's just an additional cost that people don't intuitively think about.
No. And that's why I wanted to have you on the show, because people often think, you hear the comments saying, oh, we could just add in the back, or we could just go up, or and it's just, that would be easy to do this. I think, boy, we shouldn't use the word easy in the same sentence as adding a structure, right?
Yeah, we haven't even begun to talk about the permitting requirements too, which once you make your decision you're going to go forward that and you have a decent budget, and that right there is a pretty good limiting factor, because a lot of people say, well, Pat, I just want to bump this out. I just want to add an extra 500 square feet. The cost implications are not just the cost of construction there. It's the design, the permitting, and there's a lot of different departments that are going to evaluate that. So for example, in the county of Santa Clara, typically there's 6 of them: fire department, planning department, building department, roads and airports, health and sanitation. So by the time they get done looking at it, each one of them chips in a fee, and there is a cumulative cost.
Wow. Okay, so is the homeowner navigating that half dozen agencies, or is that if they're acting as an owner or contractor, but if they hire owner builder, but if they hire a firm like yours, you're sending a man down to walk this through?
Yeah, we have actually one individual in our company. All they do is deal with permitting, full time.
I see. Okay.
And most of the time, a homeowner will typically not tackle it because it's very frustrating. And I'm not saying that in a bad way. It's
Yes.
just a complicated process, and there's a lot to it.
I know the times when I've been at the counters at different agencies, I can tell I'm a homeowner, there's another homeowner, and then there's some architects, and they're working with planning, and there's a contractor with construction boots on, and every type of individual is at the counter,
Right.
right? Okay. So
Well-
what would be the first step, though, Tim, when
Well,
they wanna
before
build
you, let me add a little bit to that. This is a business of relationships from start to stop, okay?
Yeah.
The realtor relationship with the client is one. The builder's relationship with the homeowners is another. The engineer and the builder, that's another one. And it's all about relationships. And the fact that MG has a guy dedicated to working with these jurisdictions, you can't understate how important that is, because he knows
I was just thinking that,
all of these players in the city and county buildings, and they all have their quirks and the things that they like and they don't like. So his chances of getting a permit the first time through are a lot better than yours or
somebody-
a homeowner.
Yeah.
And so there's frustration, and if your time is worth anything going back and forth, it adds up.
So let's say the buyer bought the home, it's January 1st. What's the first thing the buyer does? They hire a contractor or designer?
No,
or-
typically they're going to have to put together a design and going out. And typically that person could be an architect, could be a designer, which is a person who does the design in residential. You do not have to be a licensed architect for residential.
Oh, okay.
So a homeowner actually can govern the process. Tim may get into it later that he's doing that right now himself on his own house. So.
Right.
But the bottom line is that the homeowner can be that kind of like the linchpin of the process, or they can turn it over to somebody, and it could be a contractor, but most of the time it's usually a design professional, architect or designer. They're the person that's going to go in there and do that. A firm like ours is design build, so we would typically tackle that. So for example, we're doing a warehouse in Fremont right now for a large industrial client, and we are that person for him. He has chosen our firm to go ahead and represent him. We've brought in an architect. We're going to be doing our own structural engineering on it, but we're going to have the surveyors and everybody, geotechnical engineering. The whole package will be put together under one roof.
Right.
And so to start the process, you figure out who's going to do that, and then you start to bring together the parts and pieces. In this situation, you're going to have to identify the property line. So in red here, you got the street. Well, that property has to be identified. That's a background drawing. Then you're going to have a site civil drawing, which is going to address drainage. That's something that Tim's done quite a bit of in his past. And then you're going to have to do the actual physical drawing of the house. And then that's going to be an architect or a designer. Could be a homeowner. A lot of software packages out there right now are so,
Oh, yeah.
you know, I don't want to say simplified, but they're pretty simple. And a homeowner can do that. And I don't want to discourage anybody if they are on a budget or they're, a lot of technical people nowadays that can handle that.
Sure. Okay. The one thing we talked about the show before the show is the second story, adding a second story, or if you're buying a home that has a second story on it that was put on 10, 20, 30 years ago, maybe with or without permits, right? I don't know if we want to turn the page and do an example on that.
Yeah, well,
but-
let's look at what happens when you add a second story.
Yeah. Because sometimes, Mark, you've seen it where they've added the second story
Oh, yeah.
and it's over the garage, or I mean, you could tell by driving up, you could say,
Yeah, yeah.
oh boy, that's
Yeah,
not
yeah,
original.
Yeah, okay,
right?
so we've got, here's a house, there's the front door, there's a window, and it used to have a roof.
Right.
And now the roof's gone because they're going to add a second story. Okay, so here's the second story here and their new roof. Very simplified. Okay, so what people don't realize is there's a couple things happening structurally here that are really important relative to this existing piece. When the wind blows or the earth moves, as in an earthquake, and we're in a very seismically active area here, all this weight here wants to go sideways, like that. It wants to rack. That's how an earthquake affects a structure. It's a sideways movement, just like wind. And you can imagine if wind is blowing on this, it wants to rack it that way or this way, depending on which way the wind blows. Anyway, all of this load has to be taken by this house here. all that lateral load. And if this has no shear walls, it was built in whenever it was built, there's not one legal, current code legal piece of shear wall in this, and we
For
can
the-
talk about that.
For the layperson, the shear walls.
Yeah, so a shear wall is a piece of wall that's structural that resists racking. So in-
Racking is tilting left to right.
yeah, side to side, like that. So in this here, like this, we call this a pier. In between the openings, don't want to get too technical, but this little piece here and there, and the same thing over here, we call those piers, and they resist racking when the wind blows this direction, okay? There's very specific rules about how these things have to be built per current code in order to even count as a shear wall.
I see.
And
Yeah.
so, and guaranteed, if this thing is 50 or more years old, they don't meet those rules. So as soon as you do this, you have to upgrade all of this.
Okay, that's a good point, because as a realtor, a lot of times I pull up or drive down the road, there's a house for sale, and you could tell the second story was added in the 70s or 80s. So we know it's safe to, and the home was built in the early 60s.
Yeah.
So we're safe to say it doesn't meet any of these codes.
9 times out of 10, maybe more. Mark, what's your?
Yeah, our firm does a lot of inspections, and I would guess that 95% of them easily do not meet code, and I think Tim might even be close to 100%.
Okay.
And it's really not the builder at the time or the designer at the time.
Sure.
Building code upgrades approximately every 3 years. So, you know, for example, we used to be, prior to 1954, there was no uniform building code across the jurisdiction. So San Francisco had its own set of codes, San Jose had its other ones, LA had its different ones. And they unified that in approximately 1954. That code now is extinct. It's no longer. So now California has adopted an international building code. And Tim may get into that later, because there's a lot to building code. And so as code changes every 3 years, it gets reviewed, and they fix stuff that was, you know, previously in an earthquake something failed, then they would say, okay, let's fix that. And they would upgrade the code. So
Okay.
that's why that older house is not up to code.
Now, of course, a lot of the family, it was getting larger. They want to put a rumpus room up there, or a family room, or an extra bedroom. So a lot of times they could have just hired a contractor out of the Yellow Pages, for those old enough to remember what the Yellow Pages were, right? So when they did that, that was fine. Now we're going to sell now. And if one is to sell the house now, or people buy and sell these all the time, what would it take to bring this up to speed? Would you have to take the second story off again, that rumpus room over the garage, or would it be less
Well,
less expensive?
it's going to depend on the jurisdiction, and this is more Mark's bag, so you can talk about it more than me. But I can tell you what it takes to bring it up to current code. The bigger question, I think, is what is the jurisdiction going to actually require them to do? Because 99% of the time, it does not meet code. And people should know that going in, that if there's an earthquake, they're not in a code-compliant house. Any house built
Right, that's a
you
good
know,
point.
that built before 1990 is not going to be probably anywhere near current today's code.
Okay, so let's switch gears. Let's say there is a one story here and they want to add a second story. So the drawing up is what they would like to see. Can you speak to the crawl space? Can you use a different color here? Let's say you use
Sure.
the red for the crawl space and the piers.
Okay.
A lot of people nobody knows really, as a rule, what's going on down there.
Right. So
So
what typically you have, and this is very simplified, but you're going to have a floor system here that's held up by beams, these guys, posts, and then piers, and they run the distance all through the
yes,
crawl
sir.
space.
So it could be dozens of piers.
There will be dozens of piers.
Okay.
It's typically
And then-
35 to 50 in an average
Okay.
residence.
Right.
And then that pier we could see above ground, but they actually go in the ground a little bit as a
Yeah,
rule,
so,
right?
you know, my ground level, I'm going to draw some grass so that you
Okay.
know what it is.
Right.
Okay, so that's below ground. So you've got your foundation system down here. a continuous foundation around the perimeter, and then in the crawl space here, you've got these post piers and beams. And when you put this load up here, if there are any beams that bring load down through, guess where they're going to wind up?
Right.
Right on these, which don't meet current code at least 9 times out of 10 for what they support right now.
Wow. Okay.
Right. I mean, it's the rare case when we go in this situation that I'll calc this beam and it actually meets today's code before we do anything at all.
Okay, now this is a good point because you've mentioned in the other times you've been on the show, the crawl space is neglected. People, family after family, just move, buy and sell the home, buy and sell the home. No one really inspects down there.
Yeah.
And oftentimes you go down and you see those posts that are tilted or not touching and so on and so forth. So you really have to maintain the crawl space.
Yeah, interesting that you would mention that because our firm does a lot of work on foundations and whatnot, and we actually have a simple set of rules that we recommend all homeowners follow for maintenance of the structure, and most people don't. It's kind of like your car. If you don't change the oil in the car will have a lesser value. Well, if you allow, for example, when you look here, if you look at the finished elevation, Tim drew this rather pathetic grass there, but this actually is probably what, Tim, 2 feet down?
2 to 3 feet, yeah.
Yeah. So you'll note that water typically goes downhill, and water during the winter time will seep into a crawl space and stick around there. Well, I don't know any engineer, builder, or contractor, or architect, anybody that's going to say that's a good thing ever. It's never good.
Right.
If it was comparable to a human being, it would be like smoking 2 packs of no-filter cigarettes daily. And I mean that, no offense to the smokers out there, but you do not want water in here. But yet, probably 50+% of the homes around the Bay Area have that.
Yes.
And for that matter, the West Coast of the United States.
And that's how I met you originally. Is we were looking for a good foundation person to get some advice, and you came out. But also, you had mentioned, as well, the seminars I've attended, the downspouts come off the roof for decades, and they usually dump right next to the foundation, right?
Yep.
And that's got to be thousands of gallons a year.
And never did those downspout installers check with the engineer of record
Right.
for
There was
where to
no
locate
engineer.
them and where to discharge that
Right.
water to.
Okay.
Yeah.
This, if you could just, for the audience here, if you see where the foundation is, because
Yeah.
we call this in real estate is a post and pier and perimeter.
Uh-huh.
So there's a square perimeter, right? That if you're driving and you see a new housing track and they
Yeah.
see that perimeter, how far deep does that foundation that wraps around the building? Is that
Okay,
into
so
the
this
ground?
is the perimeter foundation
Right.
here and
Yeah.
here, and it would be on the front and back too. And this here's about 3 feet roughly.
3 feet down.
Yeah, 2 to 3 feet, something like
Okay.
that. Because there's a minimum clearance from the bottom of the floor system for people to get in here and maintain it.
And that's what's interesting is that the water can sponge around, right?
Oh,
It
yeah.
goes up and underneath the foundation and into the...
Yeah, it can go through the foundation as well if there's cracks or anything like that as well. And that we see quite a bit of.
I see.
So the house I'm living in now, because I'm building a new house, and in the interim I'm living in an old house. It was probably built in the 40s. And the floors are doing this. And there's a downspout. It's a 2-story house, and the downspout comes down, and where the floor does that, the
That's
worst.
exactly right, yes.
Okay, the upper floor does that, the lower floor does that, is right where a downspout has come disconnected from its splash pad, and all that water has
For
gone
decades,
down
yeah.
and undermined this
Right,
footing.
Right.
And so now this is settled. The rest of the house hasn't because only the downspout is here.
Now, for instance, where we have the summer and winter in Silicon Valley, the ground will swell up in the wintertime and shrink back down in the summer, right?
Expansive clay.
Right, so that will also affect the construction and cracks and...
Absolutely.
and
Yeah, actually, that's a good point. We have probably about 500 calls a year from people saying, hey, I have cracks where I've never seen them before. And, do I need to worry about that? And I'll tell you, probably 80% of the time, no. Because you're right. The soil expands, in the wintertime, expands up. And in the summer, it dries out and shrinks and loses volume. So when it shrinks, the foundation follows it down a little bit. And when Tim drew these openings in here, an opening is a weak spot in the wall. So where there's a weak spot, typically they'll see cracks radiating off the corners of windows, and it could be at the top or bottom.
Yeah.
And this is in sheetrock.
It's in sheetrock,
Sheetrock,
plaster,
yeah.
anything rigid that doesn't stretch. So
Right.
rarely do we see it with wood finishes, but almost always we see it. And I know as a realtor, you've seen it
Right.
hundreds of
And
times.
this is a good
right?
tip for the sellers and the real estate agents that represent them. We are not supposed to, when they fill out these disclosures and questionnaires, we are not supposed to say cracks in kitchen wall due to settling. We are not qualified to describe the origin of the crack. We just say there's a crack. And we'll let people like you
Yeah.
decide how it got there.
Yep.
Right.
And then we usually punt to a geotechnical engineer who's
Yeah.
a soils engineer if it's significant.
Mhm.
But yeah, there you see a lot of that, Pat. I know you've seen that, and
Okay.
you've even
Well,
got all the
so we're-
photos of
And
that.
not all cracks are a horrible thing. I
Sure.
mean, it certainly is a cause for concern. A flag should go up. You should bring in a professional and take a look at it. But a good number of the cracks that I look at the end of the day, I say, yeah, let's just keep our eye on that because it doesn't concern me. I don't see a serious settlement problem here.
Okay, now the closing out here on this, we have cracks in the foundation that you mentioned, and that could let water seep in and out.
Yep.
I understand there's ways to put the epoxy in or
Yep. Yep.
to sew that up tight,
Yep.
right? The closing
Yeah,
amendment here.
Tim and I have done quite a few projects like that. We do recommend that if you have leakage through there or other issues, no reinforcement, for example. But bottom line, it's a pretty simple procedure. It's not too terribly expensive, and you get a pretty good bang for your buck out of it.
Great.
Do you want to fix the settlement now, or should we do that later?
Can you stick around for another show?
Yeah, you
Oh,
betcha.
that'd be great. Thanks again for watching Kapowich on Real Estate. This is a program dedicated to consumer protection within the residential real estate arena. We will see you next week. Thanks for watching.